Okay, let's take a look at this program, which has an example of the call by value method of passing arguments to a function. In this program, the values of the parameters num_a and num_b are changed in the function, but this has no effect on the arguments num_1 and num_2. So let's trace this through and see what happens here. So in the main function, we start with variables num_1, which is initialized to 4, and num_2, which is initialized to 7. And we print that out. We're going to print num_1 is 4 and num_2 is 7, as we see the output down here. Then we call this function double them, and we're passing the value of num_1 and the value of num_2 to be the values of parameters num_a and num_b. So now in the function, now we're sending control to the function, and the first thing that happens in the function is that it declares these parameters, num_a and num_b, so that allocates locations for them, and then the value of num_1 is passed to be the value of num_a, and the value of num_2 is passed to be the value of num_b. And we start executing in the body of the function. Num_a gets the value of num_a times 2, so, all right, 2 times 4 is 8. Num_b gets the value of num_b times 2, so 7 times 2 is 14, and we store the values in these locations. Now, that's the end of this function. Notice there's no return. It's a void function, but that's the last statement that gets executed. So control goes back up here to the main function, and when that happens, these parameters, num_a and num_b, they go away. They're just local to the function. And we print num_1 is, and the value of num_1, which is 4, and num_2 is 7, as we see down here in the output. So that's a call by value method of passing arguments to parameters in a function. Okay, now let's take a look at the call by reference method. Now in this case, it may look very similar, but you'll see that when we're printing num_1 is 4 and num_2 is 7, and then num_1 is 8 and num_2 is 14. So the program may look very familiar, but let's take a look at what is happening and the differences here. All right, so we start with num_1 in main, which is 4, and num_2, which is 7. Okay, we print that. Num_1 is 4 and num_2 is 7. Then we call the function, but notice now I'm passing the address of num_1 and the address of num_2. So control goes down to the function, and the first thing I'm doing is declaring num_a and num_b. But notice now these are pointer parameters. So num_a is declared to be the type int star, which makes sense because we're passing the address of num_1, and the only thing that can store an address is a pointer. So we're passing the address of num_1, whatever this location is, to be the value of num_a, but again, we don't usually know what the number is, so we're just going to draw it as a pointer. Num_a points to that location. And we're passing the address of num_2 to be the value of the pointer parameter num_b, so num_b points to that location. And then, once the parameters have been declared, remember that the asterisk or the star is used for 2 reasons. In the declaration, it makes it a pointer. After that, it's the dereferencing operator. So in the body of the function, when I say star num_a, that's the value and the location pointed to by num_a, which right now is 4. 4 times 2 is 8, and we're storing that back in star num_a. So we're changing the value of star num_a, which means in effect we're changing the value of the variable num_1 back in main without using num_1. So in the function, I don't have num_1 and num_2, I only have num_a and num_b. But star num_b is the value and the location pointed to by num_b, which is 7 times 2 is 14, and we're storing that back in star num_b. So that's the end of the function. Notice that there's no return. This is a void function, but that's the last statement that's executed, so that sends control back up to main. And when control goes back to main, the parameters in the function go away, so I don't have num_a and num_b anymore, but the values of num_1 and num_2 have changed. So now num_1 is 8 and num_2 is 14. So this is the call by reference method of passing arguments to a function. And this allows the function to change the values of num_1 and num_2. So we don't have a return statement in C that can return multiple values, but you can send multiple addresses of variables to pointer parameters, and that allows the function to change the values in those variables. So a couple of notes here. Notice the function prototype and the function definition. Notice that the type is void. So when you're using the call by reference method, you're not returning something, so the type of the function is void. And notice that the type of the parameters is int star. So we just have the types in the prototypes, and we have the actual declarations in the function definition. But the types of the parameters are int star. They are pointers to integer locations. Also, again, notice that there is no return statement. So the function is void. There's no return statement in here. We're just using star num A and star num B as a way of changing num1 and num2 without actually using the names num1 and num2. So with the call by reference method, the function doesn't return. Instead, it changes the values of the variables back in main by using pointers and using the dereferencing operator. So in a given function, you can have both the call by value and the call by reference method. Let's say that in a program we've got values of polar coordinates. So let's say we've asked the user and we've prompted and we read in values for polar coordinates r and theta, and now what we want is a function that's going to calculate the rectangular coordinates. So when we call the function, there's the name of the function, we're converting from polar to rectangular coordinates. We're going to pass the values of r and theta to the function for it to use, and we're going to pass the addresses of other variables x and y for the function to change them. So this is assuming that I've declared all four of these variables, r, theta, x, and y. And again, I already have the values of r and theta. I need to pass the values of those variables to the function so it can use them in order to calculate x and y. And I pass the address of x and the address of y so that the function can actually put values in those variables. So again, this is what the function call looks like. So the function prototype would look like this. The type is void, so it's not returning, but instead we're going to put values in these locations. So we passed values of r and theta to float parameters, and we're passing the address of x to be the value of a float pointer parameter, and the address of y to be the value of a float pointer parameter. So again, float values get passed to float parameters, addresses of float variables get passed to float pointer parameters so that we can change the values of these variables. We can actually put values in them. So this is a style rule. Only use the call by reference method when the function is actually going to change a variable.